in this example, we will take one system which has 2 inputs and 1 output, and this block diagram gives such kind of system. And in this simple example, we'll try to illustrate how to find the transfer function of C by R, because there are 2 inputs. You can see here R is one input, N is another input, and we will see how to find transfer function C by R and also C by N using block diagrams and also using signal flow graphs. Now, signal flow graphs and block diagram, both the methods are useful for LTI systems and also single input, single output systems. But in this case, there are 2 inputs, but we can find out the transfer function only 1 output and 1 input. For example, when you are trying to find the transfer function which relates the C by R, we need to assume the other input N is equal to 0. Deactivate that input, then we can find out the transfer function C by R. Similarly, when you are trying to find the transfer function C by N, we need to assume this input is equal to 0. Deactivate this input and find out what is the relation between the output and the other input variable N. Finally, if you want for analysis purpose, we can add these two and we can get the equation. Your C is equal to something into R plus something into N, because any LTI system will obey the principle of superposition. So in superposition, at any time we can take one input and other inputs we can assume 0, and finally we can take all the inputs into consideration. Now, first we will use the block diagram technique and we will try to find what is the transfer function C by R and also other transfer function C by N. First is C by R. So while obtaining the transfer function C by R, I said we need to assume N is equal to 0. So if you assume N is 0, then I can simply remove that summing point. And what is the input that is coming? N, and the sign we have plus. And also from this G1, we have the output of G1 which is going to the summing point, that sign is also plus. So both the signs are plus, so therefore simply I can remove the summing point. Once you remove the summing point, it is a very standard closed loop block diagram with one summing point. And what is this? G1, G2, I can simply multiply them. Therefore my G is a G1, G2 and H is a H1. I can find out the transfer function easily by using the loop formula, that is G by 1 plus GH, which results in your C of S by R of S is equal to G1, G2 divided by 1 plus G1, G2, H1. So this is the transfer function C by R or C of S by R of S. Second case, we assume the input R is equal to 0 and we take the N as the input and the C as the output. We'll try to find the transfer function. Now in the original block diagram, when you assume R is equal to 0, so when R is 0, the R input which is coming polarity is plus, but the feedback which is coming from H1 is minus. Therefore that minus we should take into consideration. So we should take care of that minus also. Then what I am doing is I am removing the summing point. In place of that I am placing a block which is inside the gain is minus 1. So when you place the minus 1, which means the negative feedback is taken care. Then the input is N and output is C. So if we rearrange, means so this all these things are in series, right? Then N if you take here and N, I have summing point and G2 is a forward path gain. In feedback we have minus, already G1 is there and also H1 is there. So this is the feedback which you have. But what is the feedback sign? It is a positive feedback. Okay. Then we can find out the transfer function C of S by N of S. So G is G2 and H is minus G1 H1 and it is a positive feedback. For the loop formula is G by 1 minus GH. So if you substitute that, we will get it as C of s by n of s is equal to g2 by 1 plus g1 g2 h1. When you compare these two transfer functions, the first transfer function C by R is g1 g2 by 1 plus g1 g2 h1. The second transfer function C of s by n of s is you have g2 by 1 plus g1 g2 h1. When you observe closely these two, the denominator of these two transfer function is same. That means for any given system, you may take the input at any side, or you can take the output at anywhere, but the denominator transfer function will always remain same, because the denominator of the transfer function depends on mainly what are the system components that are available, or the values of system components. If the system components are same, because system components will not vary when you vary the input or the output, or when it varies where you are giving the input, where you are taking the output, so the denominator will be same. Now we'll take the same block diagram. We know how to convert block diagram into signal flow graph. Then we'll obtain the signal flow graph and we apply the Mason's gain formula to find the overall transfer function. So when you do that, it is very clear if in this block diagram, after the first summing point I can assume x1 node, then there is another summing point, I can take x2 node, and also the output takeoff point I can take the x3 node, and already I have the output C node and input is R node. Then as it is, if you represent here the directions and also transmutations, if we transfer from the block diagram to signal flow graph, the signal flow graph looks like this. Now I have R and I have x1 and x1 to I have x2 and x2 to x3 and x3 to C. There is input which is n here, the another input which is R. Then I am taking that negative feedback into consideration. This becomes the minus h1. Now, so for this I need to find the transfer functions. First transfer function is C of s by R of s. Second transfer function is C of s by N of s. When you do that, the procedure is same, because whether it is a block diagram or a signal flow graph, both are applicable for only linear time variant systems and single input single output systems. Therefore we can find the transfer function for only one output and one input. The first one is C of s by R of s. Then assume N of s is 0. So in signal flow graph, we just ignore that input, okay, ignore the input N of s, and you find out what are the forward paths available, what are the individual loops available, and what are the non-touching pair combinations, and take all those information, fit into your Mason's gain formula to get the overall transfer function. Now if you look at this signal flow graph, there is only one forward path from R to x1, x1 to x2, x2 to x3, x3 to C. Then what will be the path gain? The path gain is G1, G2. Then how many individual loops are there? Only one individual loop I have, and the loop gain is G1, G2, and also I have minus H1, which results in minus G1, G2, H1. So one individual loop. Then what is the formula? C of s by R of s is G1 delta 1 divided by delta. What is delta? Delta is 1 minus L1. That means 1 minus of minus G1, G2, H1. That will be 1 plus G1, G2, H1 is the delta. What is delta 1? When you remove all the nodes, no graph exists. Therefore, delta 1 is 1. What is G1? We already calculated G1 value, that is your G1, G2. What is the transfer function now? C of s by R of s by ignoring the N of s, another input. Now second case, we take C of s and we take N of s and we assume R of s is 0. In this case, you need not find again the delta, because delta is a determinant of the graph, and inside the delta we have the information of all the loops. So when you have the loop, then when you vary the input, the loop is not at all depends on the input. Therefore the delta is same for C by R as well as the C by N. Then we should look at only what are the forward paths available from N to C, and if you remove those nodes, whether you get any extra graph, remaining graph, that only we have to check it out. Now, so I can write directly your C of S by N of S is equal to, we have only one forward path, therefore G1 delta 1 divided by the delta which is same. What was the delta we got? Delta is equal to 1 plus G1 G2 H1. What is G1? We can see from this graph from N to C there is only one path and its path gain is G2. So what is delta 1? Whenever you remove these nodes and there is no graph exists, so delta 1 is also 1. What will be C of S by N of S? C of S by N of S is G2 by 1 plus G1 G2 H1. Therefore, when you compare these two transfer functions with the block diagram results, both are same. So C of S by R of S, here it is G1 G2 by 1 plus G1 G2 H1, and using block diagram also same G1 G2 by 1 plus G1 G2 H1. And using the signal flow graph, just now we got for C of S by N of S as G2 by 1 plus G1 G2 H1. Using the block diagram also we got the same results, that is C of S by N of S is G2 by 1 plus G1 G2 H1. So we can summarize here, whenever you have 2 inputs and 1 output, or 2 input, 2 outputs in a signal flow graph, the delta will be same. In block diagram, the denominator becomes same. So because the denominator or delta both will have the complete information of the system components.